All right, so we have moved pretty quickly through supporting and holding, stirring and heating, but now when we get to measuring, there's just an awful lot of measuring that we need to do. Matter of fact, in probably every lab that you do, you're going to be measuring things. Sometimes you're going to measure the mass. Sometimes you're going to measure the volume. Sometimes you're going to measure the temperature, the time, and even a couple things times we'll measure the length. So it's important to get comfortable using the measuring tools. You're probably already comfortable using a ruler, so length won't be that big of a deal. Although we won't be working in inches and feet, we're going to be working in centimeters, meters, millimeters. Time you're going to be familiar with. We're going to be working with seconds and minutes. Temperature will be new for you perhaps if you're not used to working in Celsius. Um, Volume, once again, we're not working in ounces or gallons. We're going to be working in liters and milliliters. And then mass, we're going to be working in grams and kilograms and milligrams. So the units may be different, but hopefully some of this stuff will be familiar. So let me start off. We're going to talk about mass. So mass is measured with a scale. And whenever you come to our orientation, we're going to have several different scale stations. One of those will be dealing with just making a distinction between the degree of precision. You might think that you always need a very high degree of precision and accuracy for a measurement. Actually, a lot of times you don't. You need to know sometimes pretty accurately what you have, but not super accurately. So some of our scales will measure to the thousandths of a gram. Others will measure to the 10,000ths. Others just measure to the single gram. And so you'll know whenever you do the lab how precise we need you to measure it, so you'll learn about that. Scales always have an on-off function. One of the things you'll figure out to do is how to turn them on and how to turn them off. Another one of the functions is the tairing function. This allows you to put a weighboat on the scale and then to have the scale say, look, I want to ignore the weight of the weighboat. And so now everything that it measures is just the weight of the sample. Other things to talk about would be hygiene. A lot of times these scales get pretty dirty because whenever you're working with samples, when you scoop out of a jar, some of that stuff gets on the weigh plate, and of course that's a problem because that some of those things we don't want on the weigh plate, but it's also just bad hygiene. So I'm going to show you a video that just walks through the use of a scale. It'll talk about precision, turning it on and off, tearing it, as well as some of the techniques for good hygiene.
This is just a YouTube video of somebody describing how to use a scale. This is actually a scale that we have. Some of the things you can tell just by looking at it is that this 400 grams here, that means that it will only weigh up to 400 grams. So it will weigh things that are, give you hundredths of a gram up to 400 grams. And let's listen in and see how he describes how to use the scale here.
So for this part of the procedure, I just want to show you guys the general basics on this. This is a spatula. This is the fat end. This is the fine end right here. All right, first thing you're going to do is you're going to put a weighboat down. Your weighboat should be clean and it should be dry. Okay, you're going to zero out the scale, which tells it to ignore the mass of this weighboat right here. And then from here on out, the only mass that this weighboat will read will be anything I add to it, which in this case is going to be our solid, whatever it happens to be. Make sure your scale currently reads 0.00. That's whenever I say make sure your scale is zeroed out, that's what I mean. All right, now keep in mind, these bottles should be closed and sealed anytime that you're not using them. All right, so here's what we're gonna do. We're gonna open this up. I'm gonna set this off to the side right here. And I'm gonna be very careful to make sure that it doesn't get dirty. Now, if I wanted to measure out 2.5 grams, 2.50 grams of this solid, I would start with the fat end right here, the coarse end of my spatula. Dig it in there a little bit. Okay, and kind of get a feel for how much each little glob of this stuff is. Now what I'm going to do is I'm actually going to stop just under 2.5. And I'm going to be very careful because the moment anything leaves this spatula, it is considered contaminated. You'll notice that I'm right about 1.76. Notice that I'm holding the bottle so that the mouth of the bottle is over the weighboat. That way if I spill anything, it lands in the weighboat and not on my table. All right, that's probably a little too much. Okay, now I want you to notice, right now at about 2.33, I'm going for 2.50. I'm going to go ahead and tap this out, and I'm going to go ahead and switch over so that I'm using the more narrow end. And I'm going to grab little bits at a time here. And I'm going to do fine measurements here. Because I don't want to overshoot my mark, because anything I overshoot is going to be waste. See, I'm at 2.49, so I'm literally just going to tap it against the side of the bottle. Now, if you've got a draft in the room there, the scale may actually cycle up and down a little bit. That's fine. Okay, we're almost right on top of it. Okay, it's about 2.5. The scale's kind of going up and down just a tiny bit. There you go. So 2.50 right there. All right, make sure there's nothing left on the spatula. I can shake it off in here like this. Okay, this goes over here to the edge of the sink like this. All right, you recap your bottle. Okay, and then you're ready to go. That's it. Good luck, and I'll see you guys in class.
All right, so that was a brief introduction to determining the mass of things. Now let's talk about determining the volume of things. A whole lot of tools that we use, basically we use the scale for the mass, but we have all different kinds of tools that we use to determine the volume of things. So we'll use graduated cylinders. Let me show you a quick video to start off with, just about how to use a graduated cylinder.
Welcome to a short video on reading a graduated cylinder. If you put liquid in a graduated cylinder, for example, here we have a 25 milliliter graduated cylinder with a certain amount of liquid in it, to get an accurate reading of the volume of liquid in the graduated cylinder, you need to make an estimate, and you're going to make an estimate at the bottom of this sort of curved part at the surface of the liquid, what's called a meniscus. And so here's an expanded view, and we can see that here's the 10 milliliter line, there's the 15 milliliter line, so we have lines showing the division for every unit, so 10, 11, 12, 13, 14, 15 milliliters. Clearly the line, the bottom of the meniscus, is more than 12 milliliters and less than 13. And then what we want to do is estimate to the tenths place in this case. And so we imagine a straight horizontal line at the bottom of the meniscus and then see where it falls between 12 and 13. And we're mentally dividing the space or the division from 12 milliliters to 13 milliliters into tenths. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. And then we're seeing where the bottom of this meniscus lies in that 12 to 13 range. To me, it looks like it's well past halfway. I'm going to say it's about 7/10 of the way from the 12 to the 13. And so I would then read this as 12.7 milliliters, where the 7 is our last significant figure, and it's an estimated value. It's certainly possible somebody might read this as 12.6 or maybe 12.8, but it shouldn't differ by too much in that last digit. And we definitely don't want to report this as 13. We don't want to call it 12.5. We want as accurate an estimate as we can. And so in this case, 12.7 would be our reported value.
All right, so that wraps up a quick introduction to mass and volume as far as graduated cylinders concerned. Next video, we'll look at pipettes and then volumetric flasks.